Good evening, everyone. Welcome to the webinar on Introduction to Pointers and Linked Lists. Before starting with this webinar, I would like to tell what is Schaffen all about. Schaffen Softwares, that is our company, is a software incorporation. We as a team are into app development, web development, software development, tutorials, webinars, and blogs as well. So I am Aisha Numani and I am working with Schaffen Softwares, and this webinar is on behalf of them only. So let's start with it. The question is, what are pointers? Many students are very nervous when it comes to pointers and they don't know how to solve programs that are based on them. Like all the data structures, they're all based on pointers. So what are pointers? Pointers, as the name suggests, pointers are the variables that point to other variables, right? Suppose this is a variable P and it points to another variable A. This is it according to what the name suggests. But this is not actually accurate because when you see pointers are actually something which store addresses of another variable. Suppose this is the variable A. It has value 10 and address 2000. Now, if we point this variable P to A, the P variable will store the address 2000. And that's how it will point to A. Now, how does this work programmatically? Suppose we have a variable of int type P and it is a pointer. We use asterisk to show that it is a pointer or not, and another simple variable A. Now suppose we assign A value 10 to A and we want the address of A to be stored in P. So we'll do like this. Now this ampersand here, this tells the address of the variable A. Now, when we see, the pointer will have the value, suppose 2000, if it is the address of A. And if we want to access the value 10, all we need to do is use the asterisk symbol. Now, suppose we want to print the address or the value. For printing, we simply want to print it like printf. This P, and it will print 2000. And if we do printf star P, it will print the value 10. It is as simple as it is. Yeah, so now let's move if we want a collection of data. Like right now we were doing just a single variable A. Suppose we have an array. How will we store it in a pointer? It is just like, exactly like how we store a variable, a normal variable. Now suppose we have an array, ARR, and we want to store this in P. All we want to do is P is equal to ampersand ARR. And this won't point to the whole array. It will just point to the first index of the array, which is index 0. So the address of index 0 will be stored in P. Now, if we want to go to index 1, suppose this is the array. 0, 1, 2, 3, 4. And we want to go to index 1. Right now the pointer is at 0. All we want to do is P++. and it will move to index 1. Now you must be thinking, how does it work so normally? Like suppose the address of index 0 is 200. When we apply p++, it won't be 201. No. It will be incremented by the size of the data type of which the array is. Suppose it is integer. So it will be increased by 4. So the next address will be 204 and it will point to, yes, the first index. Now the major problem which many students face is structures. How do structures work? Now structure is like array only, but arrays are for similar data types. Similar array. But structures are for both similar and dissimilar data types. How you must be thinking. Now suppose there's an array. It can only be of either type integer or character or float, maybe anything. But when we talk about structures, we can have many data types inside. Suppose we have 3 integers, 2 characters. We don't know. It depends on the requirement only. Now, since I'm going to teach what structures are, I would like you to either take screenshot or note along with me so that it will be easier for the examples ahead. How do we create structures? We use the keyword struct. Now, using struct keyword, suppose we create a structure str, or maybe any name like ABC I'll take. And we have the values int a, b, and char c. Yeah, it defines the name only. Right? So this is how you define a structure. Now, what if you want to declare a variable of this structure? There are two methods. Either you can declare it here itself, or you can write the whole thing again, this struct ABC, and then the variable name. Let me show you how. We have struct ABC int a, b, and char c, and we name it s right here, or maybe s1, and then we write it again, struct abc s2. These are the two ways how you declare variables of the type structure. Now let's move on to a bigger problem, which is pointers which point to variable of structures. Suppose this is your structure, the same structure as a struct ABC we have. It is struct ABC s and pointer p. Now how do we point this to this variable? It's pretty simple, just like before. P is equal to ampersand s. Easy, isn't it? Now, since the pointer points to the structure, let's discuss how to access the variables of the structure. As you remember, we had 3 variables, a, b, and a character variable c. Using the variable s, how are we supposed to access these? S.a will get you a, S.b will get you b, S.c will get you c. It's not so tough. Now suppose we have the values a is equal to 10, b is equal to 20, and C is equal to, oh sorry, it is a character, C. So when we print %d, %d, %c, s dot a, s dot b, s dot c, it will print 10, 20, c. Now using the pointer, there's nothing different, just the dot operator is replaced by arrow operator, which is nothing but hyphen and a greater than symbol. So printf %d, %c, p, and this is b and c, will again print the same thing. It's no different. This and this are exactly the same. We are just using pointers here. So since now we know how we point to a structure, we should know how structures point to themselves. We call these self-referential structures. Self-referential. Check the spelling if I'm wrong. Tell me in the live chat. So how does this work? Suppose we have a structure struct node, and what we have inside is int info, which contains the information, and another variable struct node pointer next. Now imagine this. If we are declaring a variable, how can we have the same variable inside it? How? That's nothing, because since you have already declared that this is the structure name, when you declare a variable of the same type inside the structure, it just knows that another structure can be stored inside this one. I know this is confusing. I'll show you by a diagram. Suppose this is the structure. Okay. This is the integer value. And this is the same variable of structure, the struct node next, and this is info. Okay, so when you have another structure of the same type, struct node, and it has again the same values, this is integer, and this is again the pointer. Okay, I'll just write I here and P here. So this pointer right here can point to this structure. So how does this happen? This just cannot happen. This just cannot happen like that. First we have to allocate memory to the structure somehow. Then only we can use it to store in another pointer. Let me show you how to allocate memory. We use malloc, calloc, and that's all we'll use. We also have realloc, but that is not used here. So first let me show you how to use malloc. Suppose we have a struct node like this, pointer p, okay, and we want to allocate memory, struct node Since malloc returns, it returns void. So we need to typecast here. Struct node pointer. This is typecasting. Okay, we'll use malloc here. And now we have to specify how much size do we need. So we'll use the size of keyword and again struct node because that's how much memory we need. Okay, double bracket. Now this contains 20 bytes. You must think how. Remember the struct node had two parts, integer part of 4 bytes and a pointer part of 16 bytes. Yes, the pointer is of 16 bytes because it contains the address and the addresses are stored in 16 byte. Yes. So after allocating the memory, we can easily make the pointer point to another structure. Yes. Now suppose we have two structures. This is S1 and S2. Integer part and pointer part. You must be thinking why I am making the pointer box bigger because of the size. It's simple. So this is the pointer part. Now suppose this has address 2000 and this has address 4000. This has value 10 and this has value 5. Okay, 10. Now if we store the address 4000 here, we can access S2 using S1. Let me show you how. This is S1. Okay, it was value 5 and this was having value 4000. Now S1. Since this is pointing to S2 having value 10 and this value nothing right now. So if we print S2 dot 10, oh sorry, not 10, the integer value info. I don't know what's in my mind right now. We print S2 dot info, it will print 10. And similarly, if we write S1 dot info, it will print 5. But if we want to print 10 without using S2, what will we have to do? Yes, we can use S1 of next, sorry, S1 dot next, not of, because it is not a pointer. Yeah, S1 dot next. Now next is a pointer. Remember it pointed to S2. So next S1 dot next and info. This will print the value 10 without using S2. Let's see how this works. Okay, this is easy, not so tough. We'll go here and yeah, I have already created all this. The node is here and everything. Now we have struct node S1 and S2. Okay, and we want to print, so let's just first assign the value S1 dot a, not a, info is equal to 5 and S2 dot info is equal to 10. And now we'll printf %d again %d. Let's just add some space. Yeah. Now s1 dot info comma s2 dot info. Let's see how it prints. It's not printing anything. Oh no. Oh yes, I've not saved it. Oh, what's wrong with me? Let's save this. Yeah. Now we have saved the file. And still not printing. What's wrong? Oh, we have declared also. It's showing S2 not declared. So this S. Oh. Yeah. Still. Oh my god. Okay. Okay, let me just copy this to the desktop. And now we'll save it again. Still access is denied. Okay, some error is there. We'll see this later. Let's continue with what we were studying. Let's study theory only for now. Yeah, let's start. So what we learned till now is how we point a structure to, how we store the address of a structure to a variable, and how we declare a self-referential structure. Let me revise it for you because you must have forgotten with all that error mess. So this was the structure. And this was the self-referential pointer. Okay. And this was the variable. Okay. Now we were making, no, we did two variables, yes, s2 also, and then we used s1.next to point at s2, and then we were easily able to access the value. Oh, this is info. the value info using S1, the value of info of S2 using S1. Let's move ahead. The main problem, yes, let's move to the main problem, linked list. Now, since we have seen how the structure, self-referential structure, can link two structures, S1 and S2. This was pointing at this whole structure, this whole. So, if you can represent in some easier way, suppose this and this was info and this was next, this was info and this was next. So the next was pointing to the whole structure of S2. These two structures are linked, as you can see. This is how linked lists are created. Suppose we keep connecting another structure and then another and then another. Yeah, so it's just so simple, but somehow we get confused like how this all works. Now see, the question again is how to do this programmatically. Yeah, sorry. So this was the structure int info struct node next. Now what we can do is we can redefine this using the define. It is a macro and we can name it something small like struct node it was. So we'll use define struct node list. Now each time we have to create a variable or maybe call something or maybe mostly creating variables, and while allocating memory using malloc we use this. We can directly use the word list as we have defined the structure as list. So let me show you how this works. Oh, before continuing, a form is circulated in the live chat. Everyone please fill it up in order to get the certificates if you want, of course. And who would deny for certificates? Yeah, do check. Okay, let's see how this works. If we have defined it as a list, we can simply call a variable start or s or anything. Variables are of your choice. And we don't have to write the whole struct node thing over and over again. All we need to do is write this list and declare the variable. Now this can be done with many things. I wanted to show you with programming. Let me create a new file for this. Let's see if it works somehow. Yeah. Let me save it. Why isn't it saving now? List.c. Let's see. Hash include stdio.h, and we can declare the structure and info and struct node next pointer, where next, and we can declare another pointer right here, start, because it will show the start of the list. Okay, now regarding defining, we can define it here, define struct node list, or maybe we can use type def, not define, type def. We are defining a data type, right? So we'll use type def. Let's see if it works. Now what we need to do is we'll allocate memory to this structure, list create node. We'll take the value from the user, and then we will first will allocate, obviously, p is equal to list malloc size of list. Okay, then we'll initialize the information, which is the value taken from the user, and of course we'll set the pointer to null. And we'll return the pointer because we have the data type, the return type as the list, which is declared here. Now let's see if this works first. So we'll create a main, and let's take a value from the user. Printf enter some value. Yeah. Oh. And then we'll take the value, of course, %d and %value. We have not declared it. And now what we will do is create a pointer. So let's make it start is equal to create node value. So now this will call this function, and we'll have the size allocated and the value. Oh, maybe this was the error last time. We didn't allocate the memory. Maybe this was the error. I don't know. Okay, so right now I got the info that due to some problem, the form has not been displayed in the live chat and even in the comment section. So it is a kind request. Please visit our Instagram site for the form and fill it to Okay, and the form link is in the bio of Instagram profile. Please visit there and fill the form to get the certificates. I'm sorry for your inconvenience. I'm really sorry. Okay, now this will call this function and it will allocate the memory, and then it will initialize the data. So let's move on. Now what we need to do is print. Let's print it. %d. New line, of course, because start info. Yeah, let's try. Invalid processing directive type def. I thought it worked. What's the problem? What's wrong with type def? It worked, right? Maybe it's not working here, or maybe we don't use hash. Oh, we don't use hash. I forgot. Now, incompatible implicit declaration of, oh yes, std library, standard library, you didn't include hash include standard library dot h and stdio dot h. Okay, let's start. No, both. Now, null undeclared. What does null undeclared mean? Maybe we shouldn't even initialize that. Let's try. Yeah, so while I'm saying all this, you guys just visit the Instagram profile and check the form in the bio. Okay, now what is this? Oh, print. Battery is low. Yeah, this will be print f. Let's see. Oh, we are not. It's not showing. And yeah, enter some value. Let's enter 30. It's printing 30. Yeah, it's working fine. All we did was we didn't allocate memory at first. Yeah, such a common mistake. Now, since we are allocating memory, we are also initializing the data. We are doing everything. All we need to do right now is insert. Remember how we did it while pointing? Remember how we did it? Let me show you the insertion again. Since the last program didn't work, let me show you here itself. Let's have another value like list asterisk. What should we take? Let's take s only. Now some value will do s is equal to create node 10. Okay, and the second thing which we will do is s next is equal to start. Okay, and then we'll also print %d space %d, and this will show s info and also s next info. So as we have discussed earlier, this should show something like, suppose this is the s and this is start. What are we doing right now? S of next is equal to start, right? So what we are doing is the next value, the pointer next is pointing to start, which means when we can print this using s, and we can also print this using s. Let's see if that. So oh, it's slow, I guess. Yeah, enter some value. Let's enter 45. See, first it prints the value here, the value of info. Okay, then it prints the s, the info of s, which is 10, as you can see here, 10, and then it again prints info of start, which is accessed using s, because s of next points to start. It's not so difficult, right? Okay, let's just put all this in a comment right now. this also. Or maybe we'll just delete everything in the main right now. Yeah, it's of no use. Now, since we've seen how the link works, like how we can link two structures, we can do it, we can create a function for that too, right? So we'll create void insert end, because right now we are inserting an end only, and value. What this value will be, the value which we want to insert at the end of the list. Okay, so we'll have list pointer is equal to create node, oh my god, node value. We are sending the value to create node, which will then initialize it and everything. Now start of next is equal to p. But wait, this will only insert it in the second place. We want to insert it at the end, so this will not work. What we'll have to do, first we'll have to reach the end. For reaching the end, what we want is another variable q is equal to start. Okay, then we'll move q till the end until it is null. Okay, this might be tough to understand, but suppose we have a pointer. Okay, no, this is the structure. Okay, I mean the list. Yeah, I don't know what I mean. Yeah, so this is the list. It has 4 nodes. These are all nodes. And this is the start. What we want to do is we want to insert a node at the end. So we'll initialize a variable, not p, we are initializing q, and we're storing the value start, which is the first node, in q. Then we'll move it from here to here, then here, and at the end. And then we'll store another variable, and another node p at the end. How we do this? So q is equal to start. Then we'll keep moving q until q of next is not equal to null. Okay, and q is equal to q of next. So remember, this was next. So when we do q is equal to q of next, we actually make this value inside q. So q comes here. Then again we do q of next. So q of next points to this node. Q points to this node now. Again q of next. Now q points to this node. Next of this is null. So now it will stop right here. Then we'll store q of next is equal to p. Now the next of this is linked to p. Nothing so difficult, right? Let's do it. Let's try this. Okay. So while q of next is not equal to null, q is equal to q of next. Okay, then q of next is equal to p. Okay, but again, what if the first element is not there itself? This won't work. So we'll put another condition right here. If start equal to null. What if the list doesn't exist. Now we can easily do start is equal to p and return it, because we don't want the further execution of the function. Okay. Let me just check if it works or not. Yeah. If you want to note down, you can easily note it down. So what we were doing, printf. Now let's take some random. And oh, we won't take from user now. Let's do start is equal to. We don't need create node, right? We can just insert, right? So let's do this. Insert end 10. Insert end 20. Now how will we print? Seriously, how will we print this? We don't know if it works or not. So let's make a print function also. Void print. Now see, the thing is, we are here traversing till the last element. As you can see, this is called traversal, this part here, this is how we traverse a list. It will start from the first node, the start itself, and then it will move to the very last node, the first node, and move to the very last node, covering all of the nodes in between. This is called traversal. So during print, we just need this. Okay, so let's make a list pointer p is equal to start. Okay, now while we won't write p of next is equal to null, we'll just write p is equal to null, because when p is null we want to stop. So while p is not null, print p of info and then we'll move to next node. P is equal to p of next. Okay, so it will stop when we reach the end, I mean after the end, when it is null actually. So after inserting this, we'll just